Okay, I think I have everything set. I'll try to watch the waiting room. Maybe I'll turn that off so that folks can automatically get in. Welcome to NE 415, Introduction to Engineering Analysis. This is a course that has long been on the books here at K-State within the nuclear engineering program, and even so, has not been taught for as long as I've been here. And I've been here since 2013. Um, Last few people joining. Okay. So NE 415 in this curriculum that we've put together for nuclear engineering students is intended to be a class on the use of computers for problem solving. Engineering analysis, I suppose, is an adequate title, and because it was already in the books, it was a good course name and number to use for the material that we'll go through this semester. A little bit of background on the course itself. The material that I'm going to be using for this course was largely developed in support of ME 400, the computer applications course on the ME side. I taught that for several years back, maybe 6 years ago or so. And I taught it with the Python programming language in as compared to say C++ or some combination thereof that has been used. Before I took on that class, it was taught in C++ and it had no prerequisites. So it was an all-in-one. You get to learn how to program and do numerical methods, or in this case now, play with Arduinos and so forth. And one of the things that I took away from that experience was, well, teaching programming is hard. Teaching is hard, but teaching programming is really hard. And a course like that requires, I think, that students come in with more background than we were requiring. And so not only should students come into this sort of class with a math background, you really should know how to program at least at a fundamental level, right? Knowing how to define variables, use if statements. Let's see, some more folks coming in, and conditionals, loops, whether it's for or while, and then the use of functions. So my expectation is you've seen all of those before. More folks coming in. Right, we'll have to make sure to be timely going forward. I understand this was all very last minute, and I appreciate the patience that you have. Um, Anyway, the material that we'll be using is based on that ME 400 stuff, but I am adjusting it a little bit to account for a couple of changes. One, we have a prereq of CS 209. So you should all be in here having already had a little bit of Python programming or you got permission otherwise. If that's not the case, I need you to get in touch with me ASAP so we can talk about how best to proceed. This is not an introductory programming class. In fact, I wouldn't even call it a programming class necessarily, although we will be using a lot of programming to get our business done. Okay, so again, I'll repeat, if you have not had a programming class before, then you have not met the prereqs for this class, and we need to talk. Right. I know that there might be some issues with the catalog statement and prereqs and so forth, but we want to make sure that everybody's set up to succeed. So that's the sort of the first point of business on the course. Okay. Now I can dive into the syllabus. Let me go ahead and share my screen. Okay. Are you able to see I think I see it in the preview. So if you don't see the syllabus, let me know. Okay, so this is the syllabus as is posted on Canvas. There is no required textbook for the class. The closest thing to a textbook that we have right now are notes that I had originally written for ME 400 that are all available at that link. We will be covering, I would say, about 80% of the material, and I'll leave the other 20% as sort of just additional review material for you. I'll point out where that's relevant when we get there. Okay. That material was intended to be a programming from scratch with these applications. And because it all fits into the 3 credits I talked about, it's pretty fast. Okay. We don't have to go that fast this time because, well, you've had some of the basics. And so this first part of the course, I've set it up, or I'm planning on it being easy for all of us, including me. It should be mostly review and getting you set up with the way that I do business in using Python, right? And that will require that you have a computer with VS Code and Python, along with at least these 3 libraries. Now, in order to get all of these onto your system, I highly recommend the use of Anaconda. And let me get rid of this. I will go over here to Anaconda. So if you go to the download link for Anaconda, you'll see something like this, and you can go ahead and get started. And then you'll be able to sign up and so forth. What I'd like you to consider is the terms of service. So Anaconda's terms of service have evolved over the years. They used to be much looser, I think, but they're pretty, let's say, stringent at this point. However, as a student at an educational institution, you have access to Anaconda if you sign up using your EDU email. So just use your university email. And then if we go over here to the academic policy, this shows us what constitutes being eligible. So if we are an individual, you should be able to sign the end user license agreement, which is available there. So you'll see all this when you actually download the software and install it. As far as I know, we do not have Anaconda on the M&E machines. That was something I had requested some time ago, and I don't know that it was ever installed. I will check later on today to see if it is, but my assumption is you are all using your own machines anyway. If that is not the case, and you definitely need a departmental machine to work with, let me know and I will figure out options. At a bare minimum, I have several older laptops that run Linux that would be totally fine for the type of stuff that we do in this class. You're not required to use them, but they're available. Okay. One other tool that we'll use possibly is the Google Colab, which is a Jupyter Notebook type environment. That's a good, certainly a good way to do business right now if we have no other way to do it. But there will definitely be a need for you to open up Jupyter Notebooks on your own machines and write Python programs on your own machines using VS Code. Okay, back to the syllabus. The prereqs I talked about in brief. You should have some background in Python via CIS 209 or some sort of alternative that's been approved. And you should have Math 340 and NE 495, either as prereq, you've already had them, or you're currently enrolled. I'm hoping to put out a survey tonight because so many of you, it would be kind of a pain to go through cases and figure out what you've had or what you're currently enrolled in. And so I'll make sure that everybody has had the background or will have the background, right? The reason that I am asking for folks to be in or have already had 495 is primarily for an application. If you've had 495, you already have seen some of the stuff that we use in nuclear engineering, including reaction rates. Go ahead. That I heard somebody. But yeah, by all means, if you have questions, you just interrupt me and we'll get it worked out. So the assumption is that you've had 495 or you will are in it right now, and that'll give you applications, reaction rates, cross sections, decay, the system of decay, some other things. I mean, heck, maybe you see Schrodinger's equation, which gives us a 2-point boundary value problem. All those things are just applications. There's nothing specific that you need. It's just better for context. And then Math 340, of course, is our differential equations course. That's helpful to have at least concurrently, because by the end of this course, we'll be talking about the solution of differential equations with an emphasis on those sorts of equations that show up later in the NE curriculum. So chief examples would be radioactive decay or transmutation, where the nuclide concentration evolves in time, or the neutron diffusion equation. These are like two very common forms of first order equations and second order equations. And if you've had 340 already or are in it, you'll have some of the theoretical background. Now, one important change in this class relative to what was once taught in ME 400 is linear algebra. So notice in the NE curriculum, you no longer have to take Math 551, which is applied matrix analysis. What we'll do in this class to make up for that is some applied matrix analysis, although it will be a little bit lighter, right? This is 3 credits for all of the content versus a 3-credit class just for matrices. But I think that I will be able to do the topic justice in just the 3 to 4 weeks that I've assigned to it, because there's a lot of stuff that you can learn in a matrix theory class that is useful if you get really deep into the use of linear algebra in applications, but maybe not essential. And so we need you to get good at the essentials. If you have an interest, maybe you're on the way to grad school in the future or something, it makes a lot of sense to carry on your education and continue taking additional math classes. So if you like the stuff that we do with matrices, if I've inspired you to look a little deeper, go ahead and take 551 or some of the other classes that math has to offer. What I'm hoping you do is come out of that section of the class knowing what a matrix is, how to compute matrix elements, how to apply matrices to vectors, how to set up systems like AX equal B and solve it, and then also how to set up systems like AX equal lambda x, known as an eigenvalue equation, right? So some of you who are seeing me again in this class after having me in reactor theory as you're trying to wrap up the NE requirements, you'll have a kind of a head start on that, right? Because we had to learn some of that on the fly. But this is the class where we'll kind of focus on that as a problem by itself without the other details of, say, reactor theory. Okay. As far as the work in this class, my initial assumption right now is that we will be doing 30 lessons, right? So we'll have 30 days, Tuesday or Thursday for this class. Now, notice it's a power lecture, right? So 75 minutes or so. Not a full lab time, but more than we get in just the 50 minutes that I was used to in ME 400. Okay. Associated with each one of these lessons, including today, will be a worksheet. These worksheets are built in Jupyter Notebooks, right? And you'll see Jupyter Notebooks today if you haven't already seen them in the past. And what they offer is sort of a guided or programmed assignment that walks you through some part of the programming that we have done or some part of the analysis. Not everything will be programming. A lot of it will be, especially in these notebooks, but they'll be sort of standalone. And what's neat about them is they are self-graded to an extent. Okay, there are some tests that will give you immediate feedback, and my goal in developing them, so many of them were developed for ME 400. I'm going to use many of them for this and then develop new ones for the new content. The idea is that these self-checks will give you feedback worth the majority of the points, so at least 50%. It kind of, some of it's as low as 50, some of it's higher than that, and I might change that along the way to make it so it gives you even more feedback than they currently do. But the idea is that you'll do this, you'll solve it, you'll execute the notebook, submit it, and then I will run it through this automatic thing that gives you feedback. Some of it will require manual feedback, like if I want you to write something, then I'll have to, read that myself. But what that will do is make grading 45 plus of you a little bit faster, right? Because that was, I was planning on doing this anyway, but now with this enrollment, that's going to be absolutely essential to make sure that we're all using time for this class as effectively as possible. Those will be small, sort of like imagine loading up a web page and just answering a little statement. In fact, I'll show you what it looks like in a little bit. These should not be super challenging, time-consuming things. It should be you sit with me for part of our lecture period, and ideally, if we get a place to go to sit and actually have this class as opposed to online, then we'll be able to spend the last maybe 20 to 25 minutes of that time working on these worksheets, and you'll get ready to go answers. You could have started it beforehand. They should not be super hard. If there are issues, we'll work those out. The more challenging or more in-depth programming will happen on 4 programming projects. These will be projects based on some sort of problem that's important within the nuclear engineering sphere, right? It might be radioactive decay or the semi-empirical mass formula, which if you've had 495, you might remember. Sort of an empirical fit of atomic masses and so forth. So applications that matter and will give you a taste of these sorts of things that I especially will require you to do in later classes, but some of my colleagues will as well, right? So these will be more like the like full programming assignments where you'll produce a full Python script or maybe several scripts that work together, and then along with some written description of it. So more not super large projects, not like a final project, but something that's a bit more in depth and will be, uh, let's say, it will try to tie together elements of chunks of the course. So we'll have one that talks that'll probably tie together the first 4 weeks on reviewing Python, NumPy, Matplotlib, and then some statistics that we will explore by way of something called the Monte Carlo method, which if you've had me in any 495, sorry, not 630, you know about Monte Carlo. It's a way to do simulation, right? And so we'll actually be able to do some simulation for, let's say, neutrons, right? Without having to know a lot of the physics, we can get by and learn a lot about what neutrons do just with random sampling, okay? Then we'll spend, let's see, 5, 6, 7, 8, about 4 weeks on linear algebra, which will take us all the way through AX equal B and the corresponding eigenvalue problems. And then weeks 9 through 15 will be back to specific tools, numerical, symbolic, mostly numerical, but some symbolic tools for a variety of problems. That'll include differentiation, integration, roots, finding optima, right? So optimization problems. We'll do some data modeling where we take scattered points and try to find fits through those points with lines or other curves. We'll learn how to do interpolation, and then finally we'll work out how to solve ordinary differential equations, either initial value problems or systems thereof, and then boundary value problems, sticking probably to 2-point boundary value problems and some techniques to solve those. In many cases, it will be like the ideas will be standalone. The tools will be standalone. They'll be built into NumPy and SciPy. We will learn some of the methods and how to implement them directly, right? We know how to compute a derivative, right? It's a function at some point plus a delta minus that function all over delta, right? And that will lead to a finite difference, which we can use to compute a derivative approximately. But then there are other things that we can do built in for, let's say, computing integrals or finding roots of a function and so forth. So we'll get a little bit of the theory and then a little bit of the practical toolbox that you'd be expected to use going forward, right? It's good to have a mix of both. I'm not a big fan of just teaching black box tools if you don't know how to use it, because that can be a little dangerous in some cases, or it can lead you into well, anyway, I think you get the point. Otherwise, the rest of the syllabus is just the set of required syllabi statements that I have to copy and paste every year. If you have any questions on that, don't ask me, ask them. Just kidding. Any questions so far? All right. So I'll go ahead and switch over to the slides. So what you're seeing here is a Jupyter notebook. And I have it specifically in a classic view, but the view doesn't matter. Just note that this is a Jupyter notebook. Uh, can I get a raise of hands? I think you can do that in Zoom. A raise of hands for folks who have used a Jupyter notebook before. I'm seeing a handful. If I had to guess, maybe 10% of you. Let's see, 1, 2, 3, 4, 5, 6, 7 out of 10 to 15% of you have used Jupyter Notebooks, and that I see a lot of these folks are also folks who have had me in NE 630, and that's totally fine. So folks who have not used Jupyter Notebooks, don't worry, we'll figure that out. Okay. So what is a Jupyter Notebook? A Jupyter Notebook is a file format that lives inside of the browser and lets us do both writing using Markdown formatting and code. What's cool about the Markdown is it lets us do formatting in a reasonably simple way, and it also lets us do things like math. Like I could easily put in E equal MC squared, and it will render in a nice way. So I'll get rid of that because we don't need it. So what's nice for me is I can take this and put it into a slide format, and that will let me go through some of the material in a way that lets me code on the fly along with you. This works really well in a lecture format where we don't have like a lab and all the other computers, so you can bring your laptops and follow along with me. I guess it works also here virtually. It doesn't seem quite as dynamic, and it'll be harder for me to slow down when you need help. But we'll try to make this work for as long as we need to. Okay, so Jupyter notebooks can be opened directly in the browser just like this, but they also can be opened in VS Code. Now, VS Code is a tool that I think folks have used. So I'm using it here. This is the syllabus that you saw in another form. Can you raise your hands again if you've used VS Code with Python? I'm seeing, oh, many more. All right. So I'm thinking that this is sort of a confirmation that DEN 10 whatever 160 used VS Code for the Python lectures. I believe Dr. Wanklin was using that, and then some of his colleagues who were working with that class. So if you've got VS Code and you have Python on your system, you are probably good to go. Now, I'll ask one more question, and that's when you use VS Code with Python, was it with Anaconda? So basically, who has used Anaconda or has Anaconda on their system? Okay, fewer. All right. So we'll have to see what we get into when folks start to install Anaconda. So if it turns out that you already have NumPy, SciPy, then there probably is no need to do anything else because that should be just about if you have those things, you'll probably have the rest of the modules that we need. And so I would say if you're good to go with that and you make an array, right? We'll talk about that in within the next week or so, then we shouldn't have any issues for your machine. If not, you might still want to take a look at Anaconda and sign up for the educational account so that you have all the pieces that we'll be needing throughout. Okay, we do have time though. The first today and then next time, all we're doing is basic Python. So if you have Python on your machine, you should be good to go to follow along with the syntax. You will want to get Jupyter on your machine though, and Anaconda is one way to do that. Okay, otherwise, the best thing to do if you're not comfortable with Anaconda and you want to get Jupyter up and running now, probably best to come and see me during office hours on Thursday, 11:30 to 1:30. I'm trying to have a big 2-hour block where I would otherwise have a lab on the Tuesday. So hopefully that time works. Otherwise, I'm pretty flexible outside of office hours. You just got to give me a heads up because I often don't sit in the office. I'll go and work at the library or things like that. So keep that all in mind. All right, so I'll get going on this then. So let's go ahead and get started. So I already walked through the syllabus, so we can skip through some of these things. This is some older stuff about ME 400, so you can skip that too. Right, we've got the textbook under the hood. I will give credit to the Open Textbook Initiative. So there are classes that have a certain symbol next to them in cases when you enroll in a class that says something like open source materials. Those courses typically have an additional fee, and that fee is used to fund development of or acquisition of open source materials. So I benefited from that a long time ago with ME 400. I haven't put on this fee for NE 415 because, well, I already have the materials, so I don't need to charge you any more than I've already, charged folks in the past, as it were. So the notes are here at ME 400. I plan on shifting that over to something named specifically for NE 415, but I'll leave the written stuff there for now, and then I'll build in some of the new material in the slides that we do, and then maybe give materials elsewhere if and when needed. Okay, but otherwise, if you are there at the notes, you can go ahead and make issues on GitHub to leave feedback. Like if you find a typo or something, and there are numerous typos, feel free to let me know in that way. Oh, is this not working for me? Mhm. Hmm, that's interesting. All right. So how much study is required? It's a 3 credit class, and a question that is maybe not always brought up, but should always be brought up by students is how much time should I be expected to study? Well, I tend to think that for a 3 hour class, for every hour, you should be spending about 2 to 3 hours outside class. So if we've got 3 hours in class, which is true for us with 2 power lectures, you should be spending probably 6 to 9 hours per week outside. That's either active study, doing the homework, whatever. It's not just sitting and Googling, right? That's not like a super good use of your time. That also makes me think of the AI statement that I think is in the syllabus, right? We know that GPT and other things are out there. I am willing to bet that if you copied and pasted any exercise that I give you in this class to GPT, it would solve it because this is not an advanced class. I'm hoping to give you tools that you can use in your advanced classes, but what we do in this class is not advanced by any means. So GPT will give you answers that are great. But if you do that, well, you lose out on the learning. And then when you get to the class where you have to use the method and you didn't learn the method, I'm going to be a little disappointed. Nobody wants that, right? So let's try to avoid using tools like that and learn this stuff. Okay. I'm hoping that I make it fun. I can't promise that, but I'm hoping I make it fun enough that you don't feel compelled to look at some of these outside resources. But it does require work on your part. And then how to study, well, do the work. I think the worksheets that I put together, that format is a good way to stay on task because it's all built in. There's really not a lot that you should need to go outside. Maybe the reading that's associated with it, but usually it's sort of guided in the sense that it'll tell you exactly what you need to do. You just have to, think through it a little bit. Okay. So for the lectures, come prepared. I always have a pen and pencil or pen or pencil with some paper without fringes. On occasion, I'll do pop quizzes, not graded, but just something where I get some immediate feedback in a low tech way. And of course, you should always feel encouraged to bring your laptop. Had hoped to use the detector lab before I realized the enrollment was like 2 to 3 times what I thought it would be, in which case we could have used the M&E machines and worked with that. But because that's not going to work out, you'll need to bring your laptops. Okay, talked about the assessment already. We'll stick with the normal grading routine. And then as far as the schedule, the first 4 lectures are the same ones that I have done in ME 400. And it's going to be very similar to what you had seen way back in DEN 160, as long as it's stayed roughly the same from what Kevin Winkland had done. And in my opinion, what this does is it sort of sets you up with Python, the Jupyter Notebook, and VS Code in a way to use Python like a glorified graphing calculator, which doesn't sound too fancy, but it at least gives you another tool and it makes it sort of feel like something you're probably familiar with, some TI something or other. Okay. This will also include things like loading in basic text data using NumPy, right? Something that we need if we're given tabulated cross sections or something else, and the use of matplotlib to produce plots of such arrayed data. We'll also talk about slicing, which is how we can take an array and pick out pieces of it using certain syntax with a certain logic that goes with it. But what's nice is all this stuff doesn't actually require much programming. Like there's no if statements or for loops or anything. Although they're there under the hood, we can get a lot done without using anything except the sort of specialized notation. What's great is this will set us up directly to play with vectors, matrices, and the rest of linear algebra in the weeks thereafter. We'll spend a little bit of time right before that working with statistics by way of Monte Carlo. And mostly, I think seeing a little bit of statistics now, having the idea of a random variable, being able to compute something like a mean and standard deviation, it's going to be useful for you going forward. But ultimately, it's just fun to simulate neutrons, right? So this Monte Carlo stuff, I think is just going to be sort of a pleasant activity for us before we dive into linear algebra, which I also think is fun, but you might not all agree with me as much as you will about the Monte Carlo. Okay, and then we get into the other stuff that I talked about and into the first bit of material. So by the end of this lesson, I hope that you can access Python in 3 different ways. And it sounds like you all are already able to access Python on your machines using some of the stuff you have from past classes. Okay. We'll review the variables that we can define using basic Python types and talk a little bit about what a variable is, especially in the context of Python as a programming language, as opposed to some other programming languages. Okay. Some key terms. I'll try to have this in each of the slides. Think of these as terms that you should have a working understanding of, whether that requires you write them in your notes and write a definition, whatever it takes, you should keep these terms clear in your mind. All right, you'll see them over and over again. Okay, so these include different types of programming languages, the different environments that we're using, and then these things that have a background are specific keywords in the Python, not keywords, specific names in the Python language, right? So they're special words. Now, Python is a scripting language, which means it's interpreted and not compiled. There are some tools out there that sort of blur the lines between interpreted and compiled for Python, but we will think of it as being interpreted. What that means is that the instructions we give as a human to the computer are interpreted on the fly to the ones and zeros the computer needs. Okay, this is different from a compiled language where the input from us in the form of some sort of text file, like maybe a C++ source code file, is computed to ones and zeros all at once in the beginning phase called the compilation phase. In practice, what this does is it makes interpreted languages a little faster to use. What I mean by that is if I have some problem that I want to solve with a language, in Python, I can fire up an editor, write my thing, press play, and immediately I have an answer if it works. Otherwise, I have maybe some sort of error that is given to me at runtime. If I'm using a compiled language, I might write my program, compile it, run into a compiler issue, meaning that I broke the laws of the language. I broke the syntax rules, and then I have to keep iterating. I think that the cycle of development is faster with a scripting language, which makes it kind of good for early students, early users, because well, it seems to me that over the years, students, including myself, have lost some patience, right? We go from expecting commercials every 10 minutes to every 5 minutes to now we watch 30-second clips on Vines or whatever watching these days, right? So I think the reward we get from faster cycles in something like Python, or we could be using MATLAB or Julia or some of these other things that are faster to develop in. I think it's worth it for some of the things that we do. If you go out into the industry or you go out into hardcore technical computing, yeah, there are going to be situations where learning a different language is going to be useful. If you're into embedded hardware on the mechanical side, of course, C is going to be the go-to language because that is where the support is greatest for on hardware programming, embedded programming. But if we are just trying to make a pretty plot of some data we collected in the laboratory, do we need to compile a bunch of stuff? No, right? That's silly, in my opinion. What's the right way to do it? Well, use the tool that makes sense to you. I'm hoping to convince you that Python is a tool that should make sense to you for a lot of these applications. It's not to say that things like Excel and other spreadsheets aren't. It's just that's a different tool. And maybe we'll find an application in this class where it's worth bringing up something like Excel, but we'll stick with Python. Accessing Python. So if you want to install Python on your own machine, I recommend go ahead and get that Anaconda distribution. And the reason I say Anaconda, full Anaconda, rather than Miniconda or some of these other versions of it, if you install Anaconda by itself, you get everything you need for this class. Okay, we might have to change things down the road in reactor theory or something like that, but this will give you everything you need. Now, note, it is pretty big. It's like several gigabytes, if I recall correctly. So if you have concerns, let me know. We'll get something figured out. There are other options. One way that we can interact with Python is via idle, which is the built-in Python terminal. So if we are on Windows, we can go into a command prompt, right? And I don't know if I actually have Python installed on this Windows machine. It does not look like I do, and it's going to try to tell me to get it. So I'm not going to do that because I'm going to get Anaconda later on today on this machine. I have it, though, on this other part of my machine, which is Linux, the Windows subsystem for Linux. So what I'm going to do here is just type in Python, and then I will also make my screen a little bit bigger. Hopefully that's reasonably legible. So this thing here that I have will look very similar to what you would have on a Windows machine, that black box that I would have over here if I had Python. Okay, but you'll have these three arrow cursors, and you can do things like A is equal to 1, 2, 3, and you can print out A, and you get the value. This is idle. This is how we can interactively program with Python without doing anything else, without having any other special tools. Of course, this is not the best way to program, but sometimes it's what I do, even if I need a simple calculator. Because if I'm on Linux, maybe I don't have access to like a calculator app, or I don't want to use a calculator app because sometimes the typing into it is just kind of hard, right? So I could do something like if I need x is equal to 1 and y is equal to 2, and I want to do x plus y, then I get this. Or if I want to set it to be z, then I can do something like this, right? There's your first little bit of Python for you. If you haven't seen this before, when you are in the terminal like this, the underscore is the character that is used to store whatever the last result computed was. So I evaluated this expression, x plus y. It has a value. Every expression will evaluate to a value. In this case, that value is 3, and I can get it using the underscore. Just sort of a simple trick sometimes that I use if I'm doing quick and dirty work like this. Okay, but I would not recommend that idle is used for your the normal business that you do with Python. It's a good quick way to load Python, check something. Maybe you want to import a library, make sure you have a version correct, etc. Okay. The other thing that we will use is VS Code, which of course I asked you about earlier. And if I have VS Code here, there are a number of things that I'll want to make sure I have. Well, one, I will make sure that I have the Python language support from Microsoft installed. And I have all that. This is all on the WSL side, the Linux side, but you'll see something very similar for Windows. And I hope to be showing you that next time once I get the Anaconda installation set. Okay. So then when you have Python, you'll be able to go to this, and it will give you options for using Python. What I'm going to do is just open up a new text file, and I'm going to save it as, let's see, lesson 1.py. Okay, so I can do the same sort of stuff that I did in the terminal, and I can actually make this a little bit bigger too. And if I want to press play for this, let's see if it automatically brings me, it's activating it, and then it brings me in. I don't know why it's asking me to do MPI stuff, right? Of course, so I ran it. Now this little script didn't do anything. So if I wanted to do something, I actually have to put something that will happen. And then if I press play, I get that 1, 2, 3 out. So yours will look similar on Windows. It won't look exactly like this because this is, of course, a Linux terminal, right? But I'll get that straightened out next time. So we can use idle. We can use VS Code, which also lets us see something in the terminal. And then, of course, we can use Jupyter Notebooks. So if I have a Jupyter Notebook, let's see if I can actually create one from scratch here. I wonder if... Actually, I'm going to have to figure... I don't remember how to make a Jupyter Notebook directly from VS Code. That's something I haven't done in a very, very long time. But what I can do is open up a file, right? So if I have my slides already done, so there's my 415 slides that I was just showing you before, right? You can actually load Jupyter Notebooks here in VS Code. And what you'll see here is the structure of the cells that look a little different when I have them here in the browser, but it's the same content, right? And you can press play by this little icon here, and that will do things. So sometimes in the slides, I'll have stuff that I execute in the background to make it work the way I want to, and it'll just be skipped in the slideshow. But otherwise, you'll see basically everything that I have. Okay, so this is how you could do Jupyter Notebooks in VS Code. You can use the browser or VS Code for Jupyter Notebooks. Doesn't matter to me. I think they're both great tools. Kind of depends on your preference. I got used to Jupyter Notebooks using them in the browser like this, especially for doing these presentations. And so that's probably how I'll tend to do it. Okay. So those are the three ways that I'll expect you to be able to use Python. In idle, right? Maybe there'll be something where I walk around and it's like, can you show me how to do this? Or in VS Code, as in a Python text file, or in Jupyter Notebook. Okay, all three of them are important, and you'll have to build expertise or competency in all three. Okay. And so actually talking about the slides, I will get these slides available to you once I get them reformatted to NE415. So by the end of today, I'll have this one uploaded to Canvas with the assumption that Ally, the accessibility engine, thinks that IPython notebooks are suitable. If it yells at me, I'm going to have to put them somewhere else because I don't like to have a bad grade. So if Canvas tells me that I'm failing my accessibility grade, I'm going to just organize things to make that better, and then I'll figure out what to do to make it accessible. Also, if there's ever anything that for you is not accessible in whatever way that might mean, please just let me know. I know that we need to get things into a format that is accessible to everyone. When dealing with programming content like what we're dealing with in this class, that's a hard thing, right? Because it's not just textual information that can be put into like a tagged PDF. It's in these cases, Jupyter Notebooks are live dynamic documents that I'm using on the fly. So we'll try to. I'm confident that it will work for folks. We just got to make sure that we're checking the right boxes. Okay. All right. So quick review of some of the basics in Python. So I said before, this lesson and the next one especially will be kind of low-level review of some of the basic things that make sure that everybody is up and running with the environment. And then next week we'll dive into using NumPy, Matplotlib, etc., for some array-based plotting. Okay, so the four basic types in Python are int, float, string, and bool, where string is shortened to just str. So as a first example, let's define three variables, A, B, and C, equal to the number of days in January, the number of centimeters per inch, and this course's full name, respectively. Okay. Now, if we were here in person, I could walk around and see you actually following along with me as we do these examples. Of course, being virtual, we sort of just have to agree that you'll do the work either now on the fly or later on. I'm going to try to record these lectures, especially the virtual ones, to share later on in case folks weren't able to make it. And in any case, what I'll do then is give you some time to work on it, and then I'll show you the answer. Most of these will be short examples, so it won't take like 10 minutes of debugging or anything like that. So in this case, if I want to define this variable A, we will set it equal to the number of days in January, which, if I recall correctly, is 31. Now, typically, if I am defining multiple variables, I will put them each on their own line. I think that's good coding practice. If you need to save real estate, you can use a semicolon and add the next definition. B is equal to number of centimeters per inch, which, if I recall correctly, was 2.54. Okay. And then if I want to add in C, this will be the course's full name, which is Introduction to Engineering Analysis. There we go. All right. So a couple things to note. If I run this, which in a Jupyter Notebook, I hit Shift Enter, or if I were not in the slideshow format, I could hit the play button. But if I'm here in this format, I can just do Shift Enter, and you can actually see that the number here next to in increases. because what this is doing is capturing the number of statements that I have executed, or not even the number of statements, the number of cells. This thing is called a cell block or a code cell. When I execute the code in that cell, this number goes up. So every time I do Shift Enter, it goes up. So I'm just redefining these things every time. Okay. What would be wrong with this assignment of a bool variable?
False has to be capitalized.
False has to be capitalized. Good memory, right? So if I wanted that to be correct, I would do this. So this is actually a form of markdown. This is not a code cell, right? So just so you understand the syntax, because I will have you write some things, and it would be nice if you wrote it with like a well-defined style. Taking a look at what you see here, you should be able to decipher what some of the symbols are doing. The double asterisk is making example bold. The single tick mark is making bool look like this thing that has the gray background, a good way to show a variable in the, in a text context. And then you can have a whole standoff block with these three ticks with Python as the word, and that will give it the right color coding. Or at least color coding consistent with the rest of what Jupyter is doing. And so the variable name B, the equal sign in purple, and then the keyword false with a capital F. If we had it just lowercase f, Python doesn't recognize it as being anything specific. So it's not green, right? So it's got to be the capital F. All right, so Python as a scripted language is also dynamically typed. So a variable's value and its type may change. This is opposed to a statically typed language where a variable has one type and that type cannot be changed. If you're familiar with the C or C++ programming languages, you have to declare types. So if you want an integer, you have to say that the A is an int. You have to do int A and then maybe give it its value then or give it later. Python does not require typing. There are some features in the latest versions of Python that let you set types. We're not going to use that set of features in this class. One, I think they're ugly. Two, I don't actually use them myself, so my own experience is Sketch. And three, I really don't know why. Maybe I'll learn why, and I'll fill you in by the end of the term, but we'll stick with sort of the basic version of Python that I think is good for getting work done. Now, consider this little code snippet. We've got two lines. A is equal to 99 and A is equal to 123. Is this allowed? Does anybody think it's not allowed? I hear no dissenters, and that would be correct because I can change the value of A at any time I want, and I can redefine it, right? So in this case, A is equal to 99, both initializes a variable A, and because 99 itself is an integer, that variable A has a value in int type. In this case, I'm really just assigning it a new number, but I could assign it a letter. There would be absolutely nothing wrong with me doing this. Seems a little wonky that I would start off with an integer and then switch it to a letter, but I can do that in Python, right? And I can actually run this. This would be great. If we did this in another language, maybe that would be not allowed. How about this? Well, this too, just like I said, would be totally acceptable, right? And so if I want to print out, so this is something that has changed in Jupyter maybe over time. If I want to print it out both times, I can do it like this. So in the first case, I'm printing it out and I have the string 1.0. In the second time, I have 1, 2, 3. Okay. Quick question about strings, right? I assume that you know what Python strings are. Is this the only way that I can define this string 1.0? Specifically, I'm thinking about what I use to denote a string value, these quotation marks. Is this the only option for defining strings in Python? Anybody know? Well, you might recall that you can also use single quotation marks. So if I do this, I would get the same output. Just because they are both allowed doesn't mean one is better than, or they're both allowed. I would say that double quotes are better than single quotes. So if you have the option of choosing one or the other, choose double. In fact, I think that's supported by the formal Python like coding guidelines. It's PEP 8 something or other. There's some formal guidance or standard for Python programming, and it's preferred to use double quotes. Why would you ever need the option? Well, suppose this variable A were actually quoting something from a book that itself had a quotation. So maybe something like Einstein said E equal mc squared, right? In this case, if I want to get the quote right, E equal mc squared, I would have to put it in double quotes to be, let's say, grammatically correct. The only way that I can get that within a string in Python then is to surround it all in single quotes. So there are some cases where the single quote is definitely useful. In general, though, use double quotes. I will try to do so myself, although I can't promise to be 100% consistent. All right, so we can also take a value and convert it to one of another type, right? This is not just taking a name and then assigning it a new value. We can actually change the value. So in this case, if I take that string 1.0, and there's one of my inconsistencies, I'll change that right now. If I say 1.0 as a string value, or a string literal is what that's sometimes called, I can put it into the float function. Now remember, float is one of the basic types, but these basic types also can be used as functions. And in Python, a function is a name with parentheses and then 0 or more arguments separated by commas that go into those parentheses. And so in this case, I'm taking this literal string value of 1.0 as characters and turning it into a float. Now, there's no way for me to know that that's a float, right? Because it's the same thing I get if I do print A, or if I just said 1.0 here and comment out the float, the printed out stuff doesn't look any different. Does anybody know how I would actually see for sure that A is a float after doing something like A equal float 1.0? Well, it turns out there is a function called type. And if I do type of A, it will tell me that it's a float. And so if I did type of, let's say 1.0, the literal string, it'll tell me it's a string. So you can use the type function as a way to do sanity checks. If you get yourself lost in your code and you're doing some debugging, use the type function, and that can help in some cases. All right. Conversions to bool are probably some of the most important conversions. On occasion, we'll go from an integer to a float or a string to a float if we're, say, reading numbers in from a text file. But there's a lot of places in conditional statements where we'll have to convert some number or some other quantity to a bool. And many values have an implied Boolean value, meaning I can go from an integer to a bool. And we should learn how that happens, okay? So for a conversion to bool, 0 and its cousins, like 0.0, or for strings, it would be the empty string, or there's actually a special none value in Python. Well, all of these actually evaluate as the Boolean false. So if I convert using the bool function, 0, 0.0, empty string, or none, they should all go to false. Just about everything else will evaluate to true. We'll see that in a moment. So let's take a look. If I take bool and I give it 0, that should tell me false. Okay, so in your head, think 0 is equivalent to false. That's actually used a lot in the C language, right? Where 0 is sort of a placeholder for false. If I take bool of 1, that'll be true. If I take bool of 0.1, that'll be true. Basically, anything that's not identically 0 will be false. That it will be true. Anything that is identically 0 will be false. Okay, you can verify these things. Like if I have the empty string, right, nothing there, that'll be false. It gets a little bit tricky though. Let's put a space. You might think that's an empty string, but it's actually containing a character, the white space character. Python doesn't believe the white space character is false. So if we do this, we'll have true. So keep that in mind. We can also use the special value none. That will evaluate to false. What is none used for? Well, none is special and I think unique to Python. There isn't really an equivalent in C or C++, but none is a suitable. Basically, if you, I don't know, the place where I have seen none show up more often than not is if I have a function. Functions can return values, but they don't have to. And if I have a function that does not return a value and I assign its return value to a variable, then I will get none. We're not talking about functions yet, but I assume you know functions. So let me do a very quick example. So I'll make a function called fun, and I'll give it an argument x, and then I will do pass. Pass is a placeholder that says, hey, I'm valid code, but I'm not doing anything. So this function does absolutely nothing. If I wanted to do something, I could do print x. We'll do that, right? And so if I do that, and then I say y is equal to fun of 1.5, right? I would expect it to print out the 1.5. And maybe if I'm not being careful, I might think that y should have the value 1.5 or something, right? And now if I print out y, what will I get? I get none because this function, even though it takes in this argument x and then prints it off, it does not return any value. So it implicitly returns none. It's a goofy part of Python, but it's actually really useful. It can be a very good way to debug. I've had that's where it shows up for me is I make a function and I will forget to return a variable. And then I'll get some sort of runtime error message that says, hey, you can't add a none to an integer or something like that, and I'll know exactly what had happened because I know where nuns come from. They come from mistakes in the functions that I make. All right, so in everything that we're doing right now, we are using the equal sign as the assignment operator, which is what gives values to names. In other words, that's what defines a variable. So in Python, a equal 1 defines a variable named a with the value assigned to it being equal to 1. In Python, there is no declaring a variable without its value. You can declare variables in statically typed languages like C or C++. You can say int a and not give it a value, and then it's uninitialized, which can be its own set of problems. But in Python, when we make a variable, we are doing it with assignment all at once. So I'm hoping by this time you have at least become aware of the three ways I'll expect you to interact with Python. You should be able to use Python basic types to define variables, and you should be able to explain, maybe to a kindergartner or at least a first-year college student, what a variable is, at least in the Python language. So I think that gets us pretty close to the end of class. Maybe that would be about 10 minutes. And I think that's roughly what I'm going to be shooting for. These lessons, the slides that I put together for ME 400 were always suited for a 50-minute lecture. The reason I wanted these power lectures is because ME 400 was always 2 lectures a week with a laboratory session. I think that by having this additional 25 minutes, typically, of course, we had some syllabus stuff to get through today. We'll have time to go through and work on some of these worksheets. The first one of which I will have uploaded to Canvas by the end of the day, and probably the one for Thursday's lesson too. These worksheets will be due on the Friday of the week in which they are assigned, and then with the office hours on Thursday, that should give folks time to talk with me as needed. And if we have to shift that office hour time based on popular opinion, I'm willing to do that within reason. But yeah, any questions that you have right now? We've got 5, 10, 15 minutes left. And if there are no questions, of course, I will repay all of the minutes I've stolen from folks throughout the years.
Will the lectures or notebooks that you use in class be shared before lecture? Like, will it be posted anywhere?
I will try to, yes. So I intend to have these be available as well. Of course, with trying to track down the room and think, I'm a little bit behind where I want it to be due to the logistics that we're working out. But yes, I will plan to have all the Jupyter notebooks available beforehand. And whether they are on Canvas or somewhere else to satisfy the accessibility, I'll make that clear too in Canvas. So there will be at least a link to them. Good question. And then I see something in chat. Let's see, are the worksheets one attempt to get the right answer or multiple attempts? So that's a great question. When I originally put it together, my intent was for the system to be fast enough for me to turn around. Like if you got it to me by close of business on Wednesday, I could get them back by close of business Thursday, in which case you'd have an additional day to work on it. If I can get the system worked out where I can reliably act on that policy, I will update the syllabus to reflect it. I'm hoping though that the worksheets themselves are not like you'll get the feedback and you'll know what went wrong. In some cases, we'll probably find that I had glitches that made it just like silly, and I'll give full credit. So if you think about it, the worksheets are worth 30%. There are 30 worksheets, so they're basically 1 point out of 100. I'm not intending for these to be like super hard where you're like working all sorts of hours to just muster 60% on them. I want them not to be freebies, but they should not be awful. So I will attempt to get the system worked out where I'd be able to get the feedback to you fast enough so that you could correct it. I'll think about other ways that I could do it, but for now, I will view it as you turn it in, and that'll be the grade. But good question. Any other questions?
What I might have missed it, but is it like in your theory to where it's 2 lectures after the worksheets are due, or when, how far after the lecture that is the worksheet due?
The worksheets are due the Friday of the week, so you'll have the first two will be due this Friday. That will, for me, that will keep us. So for reactor theory, I think I always gave about a week. So rather than have worksheets be due every lesson, I mean, I thought about doing it where it would be due each one would be due a week after, but I think it'll be easier for me to handle them in kind of a lump download because I've got to still work out some scripting things for doing the auto scoring. I'm hoping I could get it where I download everything and then I can re-upload everything to Canvas without having to enter anything beyond the notebook grading that I do. So we'll stick with Friday of the week that they are assigned. If any of the worksheets ends up being like way more time consuming than even I realize, right? Like they've been tested by a number of students at this point, both back in the days of 400 when I taught this as an online summer class one time, and then I've had some students that I've had in a special topics classes give me some feedback in a first go, and then I had some students in ME 701 also give me some feedback by as part of their semester project. So I feel pretty comfortable that the content itself is not like over the top. It should be totally doable within the time allotted.
Okay.
But this is a much larger sample size, and so we'll see some more variation, I'm sure.
So just to double check, I'm hearing you right. So we'll get assigned a homework or one of those worksheets on like Tuesday and Thursday, and then the Thursday one will be due Friday as well. So we'll only have one day for that one.
That's correct. So the idea is that we'll have time during the lecture period, right? So even now we had close to 15 minutes of extra time. I don't think that these worksheets should take more than about an hour, maybe two. It depends on how much, every person's going to have different experience. But yeah, it'll be something where I'm hoping that by the time you walk out of the lesson, you'll have already made reasonable progress. Probably is a reasonable idea also to get started before the lesson, right? Because you'll have the reading material in advance, at least for the stuff that I have done now. I'm hoping that I get ahead and have everything set to go for the other things. But it should be the case that you can get started before the lecture, and then the lecture can kind of fill in some of the gaps. Maybe an example I show will help you get past something. So as long as you become familiar with it beforehand, you should have no problem getting it done within an hour or so after the lecture time. Uh, But again, if that changes, like, or if that proves to be incorrect, then we'll handle it. But I am definitely hoping not to be talking for 50 minutes, or more than 50 minutes on these lessons, which will give that additional 25 minutes as sort of a hands-on lab time.
And then one more thing. So for the readings you talked about before lectures,
Yep.
I know you posted that link for like the past ME 400 things. Should we reference that, or like once you start posting the Jupiter stuff, is that more what we should reference instead, or kind of how
So
should we go about that?
the ME 400 stuff, so a lot of that material will stay the same. There are some things. So if you look at the material, if you went to ME 400, in fact, maybe I can just do that. Right. So it's all here. Yeah. So like when we get, so the first four lectures are, but I'll be basically keeping those the same. I might downplay the matrix vector operation stuff and push that a little bit later. But then some of this stuff like conditional statements, loops and functions, like that stuff is content that I assume you have seen to some degree, right? We'll talk a bit about text processing as part of the other stuff, but I'm hoping some of this stuff will just be replaced with linear algebra stuff. The content will stay there, and maybe I'll actually offer some of the worksheets associated with that stuff as like extra credit or something specific, intended for folks who might feel like they don't quite have the background that they thought they did. But yeah, but by and large, after that, though, from like lecture 19 on, I think everything is set. What I hope to do, though, is switch all of this stuff over to a separate site. And I'm not sure if I'll get that done this semester. It's kind of I mean, this took a lot of time to put this all together. But you'll have any material that's not on this, you'll have in advance in some form.
Okay, thank you.
Yep. And then will this recorded lecture be posted? Yes. So I do this with Zoom, and then I will upload that video to YouTube as soon as it's done processing, and then I will put a link to a YouTube channel where you can find all the lesson videos. I can't promise that I'll do recordings if we get into a classroom, because that, of course, there's time to get to a classroom and so forth. Hopefully I can, because I think it's good for posterity. But yeah, I'll use YouTube because MediaSite's kind of I don't like using MediaSite, but there'll be a link on Canvas.
Would you also recommend we have the Anaconda stuff like downloaded and taken care of before next lecture, or is there a
I think so. So if you don't have these other, like if you're in Python and you can't import NumPy, yeah, you probably want to do it. If you have NumPy, it could be that you have everything that you need. But yeah, if you don't have everything that you need before Thursday, do try to get the Anaconda installation.
Okay, thank you.
Yep. All right. If there are no other questions, we'll break off here and meet again on Thursday. Heads up for any comments for me on getting a room. We'll keep it online at least for this week. Maybe we'll be in a room next week. Either way, I think we'll be successful in this because, well, if we're in front of our computers and we have all the things we need anyway. So thanks for your patience and have a good first week of class.